Today we are in Roskilde testing a St. Eriks Air Plus roadside element. This concrete element has been produced for 1 year ago, coated with a photocatalytic solution and has been sitting outside our factory for almost a year in the sun and in the rain to test the stability of the surface. Today we will pump polluted air from this setup through this tubing over a measuring cell attached to the concrete element, and then we will pump the air back to the system, and on this screen we can read the amount of nitrogen monoxide and dioxides. We are adding some extra pollution, so we have a concentration of around 400 ppb of NOx. Today is a cloudy, typical summer day in Denmark. Of course, right now the sensor is covered, so there's almost no UV light. When we remove the blanket, we will measure the amount of ultraviolet light, and it's around 0.2 milliwatts per square centimeters, and that is typical for a very cloudy day. So now the UV light, tiny amount of UV light, enter the surface of this element and activate the photocatalytic process, and the process starts to degrade the nitrogen monoxides and dioxides, oxidize them to nitrates, and bind them to the surface. And if we look at the graph, we can now see how the pollution level is dropping drastically from 500 to 150 or something like that. So on a very cloudy day like this element is capable of removing at least 75% of the pollution. And when we cover it again and thereby block for the ultraviolet light, and stopping the photocatalytic process, we will be able to see the pollution level increase again to these 500 ppb. And here we go. So what we see here is that even on a very cloudy day, the St. Eriks Air Plus elements are extremely efficient to remove